Hello everyone. In this video, we are going to solve this very famous Monty Hall puzzle. So there was a game show during 1970s in USA. The host of the game show was Monty Hall, and he came up with this puzzle. So let's understand what this puzzle is. Suppose you are on a game show, you are the contestant, right? And you have three doors in front of you. Behind one door is a car. Let's go with Ferrari, right? And behind the other, goats. So let's say you have these three, and behind two you have doors, and one has this Ferrari car. Now host knows which door has a car. This is one very important point. Of course, host knows which door has the car, but you don't. Otherwise you would definitely choose the door with the car. So let's pick this one. So you have just three doors in front of you. This is the host, and let's say this is you. Now host will ask you a simple question. Which door do you want to pick? Now, of course, you don't know anything, right? So you will randomly pick one door. Let's say you go with door number one. Let's say you picked door number one. Completely random, right? Now, this host, Monty Hall, he knows which door has a car, right? So the host has now two options, either door number two or door number three. What he will do is he will pick the one which has a goat, definitely, and open that door. Let's say he opened door number three, and tada, you can see a goat inside this door. Now, Monty Hall will give you, this host will give you one option. Do you want to switch your choice, or do you want to stick with the choice that you picked before opening this door? So you pick door number one initially. Do you want to switch to door number two? That is the problem statement, right? So pause this video, take 2 minutes and think, what will you do? So the correct answer is you should always switch. Now, how, why you should switch? So let's discuss that. Let me clarify this. If you are thinking something like this, let's say you have three doors and initially you picked door number one. So you had 33% chance of winning the car, right? Of course, you can randomly pick this two. Otherwise, these two has 67% of chance to be picked combined, right? So 1/3, and that is around 30% of winning the car. Now, after opening a door, now you have just two doors. If you are thinking, even if you switched, your percentage is 50-50. If you stick with your previous choice, now that only two doors are available, the probability is 50-50 for you to win the car, right? Not exactly, not exactly. Why? Because these two events are connected. They are not independent. Like this is not one independent event and this is another independent event, right? That's not the same. These two are basically connected, so you need to think them in connected form, right? So now let's discuss how the probability is going to change, why the probability is not a 50-50%, right? Okay, so I will discuss two explanation. First one is going to be pure mathematical. For this, you need to know how probability actually works, right? The basics of probability. This is going to be pure mathematical explanation. Then I'll go to the next explanation that will be completely logical. So whichever you will like, you can explain or keep in your bucket of tricks. All right. So what we are going to do is we are going to create the probability tree. Don't worry about the name. It's going to be a simple mathematical funda, right? So let's say in this situation, door 1 and 3 has goats, and door number 2 has this Ferrari car. Now, this is the step. Initially, host Monty Hall asked you to pick one door, right? You could have picked any, either door number one, or door number two, or door number three, right? Now, what's the probability of you picking these doors? Can I say the probability is nothing but 1/3 for each one of them? No, picking door number one, probability is 1/3. Picking door two, probability is 1/3, and so on. So let's write, this is door number 1, door number 2, door number 3, and probability is nothing but 1/3 for each of them. Why? You are picking randomly one door, right? So this is your initial pick. Now, see, if you pick the door number 1 initially, can I say out of door number 2 and door number 3, Monty Hall knows that door number 2 has a Ferrari, right? So Monty Hall definitely will open door number 3. He cannot open door number 2, no. Door number 2 will have Ferrari, you will see it. So he will have to open door number 3 with probability 1. He has no other choice than picking this door number 3, right? This is Monty opened door. Again, if you pick the door number 2 initially, you guys, then think which door can Monty pick. So if you pick the door number 2, now Monty can open 3 or 1, any of these doors, right? So let's say Monty opened door number 1. Second scenario is Monty can open door number 3 as well. So now that Monty has two choices, the probability of picking door number 1 or door number 3 is half. He will pick each one of them with half, 50% probability. He will either open this one or this one. And the last one is, if you chose door number 3, again Monty has two choices, either 2 or 1. He cannot open door number 2. He has to open this door number 1. So he will open door number 1 again with probability 1. He has to open door number 1. Monty does not have any other choice, right? Now it's your turn. Again, Monty opened the door. Now Monty is asking, do you want to switch your choice? So let's say you prefer switching. Then we'll see what is the probability of you winning the scenario. So if you are switching, you initially chose door number 1. Monty opened door number 3 and you are switching. Can I say you will simply pick door number 2 then? Of course, this is open initially 1, then you will go to the 2, right? Then this is, you chose door number 2. Monty opened door number 1. You chose this one. Monty opened this one. You will switch to door number 3. If this is the scenario happening, you will switch to door number 3. Then next one, you guys. If you chose again door number 2, Monty opened door number 3. Can I say you will switch to door number 1 in this scenario? Again, the last option, that is you pick door number 3. Monty opened door number 1. So you will switch to door number 3. Now this is you switching. Door number 2, not 3, but rather door number 2. You pick door number 3. 1 opened. You will switch to door number 2. Now you can see, out of all these scenarios, if you switch, you are winning in these two scenarios. These two are your wins and these two are your losses. Let's calculate the overall probability of you winning. If you calculate the overall probability, all you have to do is multiply these probabilities. These probabilities 1 by 3 into 1. Again, this is 1 by 3 into 1 by 2. 1 by 3 into 1 by 2. This is 1 by 3 into 1. If you will add the probability of winning, that is these two, the probability is nothing but 2/3 to win and 1/3 to lose. So this is what is going on. Basically, if you switch, you winning the Ferrari has 2 by 3rd, that is 67%, around 67% of chance, and you losing is around 33% of time. 33% of chance, right? Of course, it does not mean you are going to win. It's just mean mathematically you have higher chance of winning, right? Okay, if this is lot of mathematical stuff, if this does not make sense to you, if you are, let's say, slightly uncomfortable with probability and these trees, if you forgot all of this, I have another way to explain this to you, right? The other way is logical explanation. Let me show you the logical explanation. Now for that, let's think we have 10 doors instead of 3. Right. Okay. So if we have 10 doors instead of 3, again, Monty Hall asked you to choose one door. Now, let's say you pick door number 1. If you picked door number 1, can I say you have a probability of 1 by 10 for each door? Initially, when you picked door number 1, you winning the Ferrari has a probability of 1 by 10, right? Now if you will see carefully, what is the overall probability of this range, you guys? The door you picked, other than that, this whole region, if I create a region here, what is the probability of this whole region? Can I say the probability of a car to be in this region is nothing but 1 by 10 added 9 times? That will be 9 upon 10, correct? And this is of course 1 upon 10. Now comes the second situation that is connected to previous one. Your host Monty Hall opened out of these 9 8 doors, not one but rather 8 doors. He opened this one, 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 and this one. And all of them definitely has goat. Each of them, you can see a goat behind it. Now Monty Hall asks you, do you want to switch? Now both the events are connected, right? You can see this door has a probability of 1 by 10 and this whole region has a probability of 9 by 10. Now that out of 9 8 doors are opened, no, probability got concentrated to this single door. Now the probability of car being in this door is not 50-50, but rather this is going to be 9 by 10 and this still has just 1 by 10, right? So you are always going to prefer switching your option. In 10 doors you are going to have 9 upon 10 scenario to win the Ferrari if you choose to switch, right? So this is one logical explanation. The only thing was the Monty Hall is opening all the doors except one. Same here. The probability in this range was 2 by 3. He opened all the doors except one. Switching is always better, right? So these two are the explanation, whichever you like. This is pure mathematical explanation. You cannot deny this. This is incorrect, right? This is slightly logical explanation. How it is getting concentrated is again will be explained by this mathematical explanation, right? So that's your Monty Hall problem, you guys. Okay. And I will see you in the next puzzle. Till then, tata, bye bye, see ya.